Good afternoon. Are you able to see the presentation? Hello, am I audible? Am I audible?
Yes, sir.
Are you able to see the presentation?
Yes, sir.
Yeah, we will continue with the remaining processes of cloud service management. So before that, maybe we'll quickly go through the so in the last lecture we started with the cloud infrastructure framework, right? So this cloud infrastructure framework so mainly consists of the four components. Okay, so the physical infrastructures, virtual infrastructure, virtual and platform softwares, and cloud infrastructure management and service creation tools. So this was discussed in the last lecture. So where the physical infrastructure refers to all the compute resource, storage resource, and network resources. So those are the physical components, right? So where the computing resources is nothing but all the physical servers, so which are connected to the your storage through the network, and also the clients will interact with the physical servers through the network. So the physical infrastructure represents all the physical hardware, right? So which may be the physical servers or storage or maybe the network related components. On top of that, what you see is the virtual infrastructure, right? So with the help of that physical infrastructure, you are going to create the virtual infrastructure, right? So this virtual infrastructure based on the type, it may be if it is related to compute in the sense you will get in the form of virtual machine, right? Where you can specify you can explicitly specify like so what amount of the processors or what amount of RAM is needed and all. And similarly for that virtual storage will be provided in terms of volumes. And also you can have the virtual network, right? So virtual network components are maybe virtual switch or virtual NIC and so on. Okay, so once you have this virtual infrastructures, right? It may be virtual machines or virtual volumes and all. So on top of that, that application will be installed, right? So that is what application and the platform software, right? So applications and platform softwares are installed, and that will be offered as a service to the cloud customers, right? So based on so this service offering may be maybe it may be software as a service, platform as a service, and infrastructure as a service, right? So where infrastructure will provide only core infrastructures and platform which provides core infrastructures along with the suitable platform without any application. And in the case of software as a service, it provides the software applications. And last one on top, what we see is yes, in order to manage all these the virtual and physical infrastructure, so that is managed by what is called as a cloud infrastructure management and service creation tool. So that is responsible for managing this virtual and physical infrastructures. Then after that, okay, so this is what about uh, first three, right? And cloud infrastructure management and the service creation tool. So that was explained with the with the different subcomponents which we already studied, right? So where virtual infrastructure management and service creation tools may be once again be classified or as a different layers like virtual access, user access management, user unified management, and virtual infrastructure management. So whenever you have this virtual infrastructure, right? So virtual infrastructure, it may be compute resource, or it may be storage resource, or it may be a network resource, right? So for each there is a separate dedicated the management software. For the storage components, for storage, you have a dedicated storage management software, and for the network to manage, you need a separate network management software, and for the compute, you need a separate management software, right? So that is what about the bottom one. So that is virtual infrastructure management. On top of that, what you see is a unified management, right? So unified management, as the name indicates, which provides the common interface, right? So through that common interface, maybe you can configure uh, all the resources, whether it may be compute, or it may be storage or network related resources. And one more important function of this unified management is a creation of the service, right? So that is also one of the important functionality of the unified management, right? So whenever we talk about creating a service, right? So that creating service mainly involves the different maybe set of processes, right? So what are the different processes? It is grading resource, bundling resource, defining resource, and distributing resource. All right. So what is a grading resource? So which we already discussed, right? Where so when you look at the physical resources, right? It may be compute, network, or storage. So that may be of maybe different quality or a different performance, right? So based on that, you grade those resources as maybe you have seen, right? Maybe that grade as the gold grade, silver, bronze, and so on, right? So based on the performance, you are grading the resources, right? So individually, you are graded compute, storage, and network resources. Okay, then after that, yes, you are going to bundle all those resources. That is, you are bundling compute, storage, and network resources. Okay, so once you bundle that, yes, you are defining the resources, right? You are defining the resource, and you are providing the resources which are specified in the bundle. All right. So once you define the service, then distributing the service, in a sense, actually you are creating an instance of the service. You are going to create an instance of the service. Okay. So user management software, and on top of that, yes. So user access management software. So user access management software is it is a so normally it will be a web interface, right? So uh, uh, through which the cloud customer will going to access the compute resources, right? So maybe if you want to access Amazon resources, they will provide Amazon portal through which you are going to access their resource. And user access management also provides even administrator who want to publish any new service catalog and all, so that also can be done through the user access management software. And similarly, for generating the report for the consuming resources, so that everything will be provided by the user access management software. And also one more important component is the authentication. So that authentication is also, it is a part of user access management software. So before allowing the user to access that service, right? So your authentication or authorization, which decides what are the resources a user can access. Okay, then after that, we have looked at the different processes, right? So the different processes for the cloud service management. So we have discussed three, I think, three or four we have discussed. That is service asset and configuration management, capacity management, performance management, and incident management. So today we'll look at the remaining processes, that is problem management, availability management, service catalog management, financial and compliance management. Okay, so we'll quickly go through this. What is the service asset and the configuration management? So what exactly it does, right? So when you talk about this cloud resources, right? So the cloud, it contains maybe thousands of servers, and maybe huge storage resources, and also maybe number of the network related component, right? So this service asset and configuration management which maintains the information attributes about all these configuration items. Right. So what all the information is configuration item names and who are the providers for that particular component, serial number, version, and in inventory status. Okay. In case if new component is added, all those information will be managed by this service asset and configuration management. And it is also responsible for maybe it also store the dependency information or dependency or the interrelationship information, right? So what are the different interrelationship information like service to a consumer, all right? So who are all the consumer is accessing that particular service, and which VM to service, which are all the services are running in the particular virtual machines, and also physical server to the virtual machine, right? So even the physical server can host any number of more than one virtual machine, right? So each virtual machine may run a different application. So that dependency or the relationship is also maintained. And similarly, physical server to the switch, right? Which are all the physical servers are connected to the which switch. Okay, so what is the use of these dependency or interrelationship? So whenever a particular component gets failed, right? In case if it is a switch, okay, if it is a switch is malfunctioning, maybe we'll come to know that. So this will have, it is going to affect, these are all the servers which is connected to that particular switch. Similarly, for maybe if a particular physical server is not functioning, okay, then or maybe the maybe resources of that particular physical server, okay, if it is less, okay, then we will come to know that. So because of that, what all the virtual machines gets affected. Okay, the same thing we apply to VM to service. Okay, if VM has a problem, what are the services gets affected and all. Okay, that is what mentioned, right? If any component fail, we'll come to know that what are the other components gets affected. Similarly, maybe if you make any changes to one component, right? For example, if one physical server is upgraded, all right, so which are the virtual machines gets benefited, all right? So where let's say that we are increasing maybe a RAM of one particular physical server, all right? So because of that, maybe some of the virtual machine which are running on that server, we can scale. So that is about user asset and configuration management. All these informations are stored in a database called as a configuration management database. So one important thing is that whenever any changes or maybe the physical infrastructure, all the components, okay, any changes made, right, it should be reflected in the configuration management database. So that is about service asset and configuration management. Then after that, we looked at the capacity management. Okay, the capacity management is responsible for allocating the resources to the particular virtual machine running, right? So it may be, yes, add capacity or reclaim the excess capacity, right? In case the virtual machine is underutilized, where we have already provided more resources, maybe you can reclaim the excess resources. Okay, so that is what is called as the capacity management. Okay, here under this, they also mentioned that even procurement of any component also is coming under this capacity management. So that is plan for procurement and the provisioning of capacity when needed. Okay, so another is about this performance management, right? So as the name indicates, which monitors and measures the performance of the cloud infrastructure resources and services. Right, so analyze the performance statistics and identify the resources and services that are performing below the expected level. In case if it is performing below the expected level, maybe you increase the resources. So how it will be increase the resource? Maybe yes, it will work with the capacity management process, right? So that works with the capacity management to implement any capacity changes. Then after that, we discussed about incident management. So what exactly that incident management refers to? Yes, an incident is an unplanned event that cause or may cause interruption to the cloud service or reduce the quality of the service, such as the degraded performance. Okay, some event will happen. All right. So it may not stop that application running, right? And if you don't solve that incident, right? If that incident get repeated, then it will degrade the performance of that application, or that application itself may failure. Okay, so whenever that incidents happens, immediately you have to take the appropriate actions, right? So that is what mentioned. An incident may not always cause the service failure, but if it is repeated, then there is definitely the service may fail. So one example they have taken, right? Maybe with respect to the RAID configuration, right? So when you talk about this RAID configuration, right? So even though we think that we are writing onto the single storage, but with the RAID architecture, it will return onto the multiple disk, right? Even one disk fails also, the data will be available on other disk. But it is a failure of one disk, and you have to handle that. That means that failure disk has to be replaced with the other other storage, or you have to allocate additional storage. Otherwise, if other one which is already working, if that also uh, if that also fails, maybe you may lose the data. Okay, so any incident happens, is it will maintain the incident history, right? So what are the symptoms, right? So the details of incident symptoms and affected the service and consumers who are all get affected, right? uh, Okay, then how much time is required to resolve that incident, and what is the severity, maybe high, low, or medium, all right? So then description of the error, all those information will be maintained. Okay, so what is the need for this one? So this will be given as input to the problem management. Okay, so this incident management, what it does, it provides the temporary solution. In case if there is a maybe a component fails, it tries to provide a temporary solution. But at the same time, you have to make sure that the component which is failed, okay, it has to be replaced with the new component, or it has to be replaced with the new component, right? So maybe one scenario is mentioned. Suppose if maybe one server gets failed, all right? So the virtual machine immediately you need to, or if one server fails in the sense, immediately the temporary solution is that we need to migrate the virtual machine running on that server to other machine. That is a temporary solution. Okay. Then immediately after that, you have to rectify you have to find the root cause of that server. Okay, or you have to replace it with some other server. Okay, so incident management involves multiple support groups to solve the incident. Okay, so it may be maybe service desk or technical support group and hardware and software manufacturers. Okay, so initially maybe if the end user or customer itself maybe find maybe there's some incident happened, and because of that some application is not functioning, directly he will register that incident with the maybe a service desk. Okay, so they may going to provide some of the solution from their end, right? If then also it is not possible to resolve the issues, then they will hand it over to the maybe a technical support group. Okay, and the technical support group, if they are also not able to solve the issue, then directly they'll contact the hardware and software vendors who actually provided those components. Okay, so next we will look at the problem management. Okay, so what is problem management? Yes, the goal of problem management is to prevent incident from exhibiting the common symptoms called problems from happening, to minimize the adverse impact of the incidents that cannot be prevented. So a problem occurs as a result of multiple incidents exhibiting the same common symptoms. So the problems can also be identified from a single significant incident that is indicative of single errors, for which the cause is unknown, but for which impact is high. The problem management prevents incident from repeating and minimize the adverse impact of incidents that cannot be prevented. So the problem management prioritizes the problem based on the impact of uh, so business and takes the corrective actions. Okay, so as I mentioned, any incident happens, right? So that will be the information about that incident is maintained, and that will be provided as a input to the problem management. Right? If some incidents happens again and again, definitely that is going to create a problem, and whose impact may be very high. All right, so this problem management will identify so those incident and try to resolve those incident at the initial level itself. Okay, so that is what mentioned here. So this problem management, it identifies the root cause of the problem and initiate the most appropriate solution for the problems. Okay, so as I mentioned, it identifies the root cause. So what is the root cause for the problem? But in case of incident management, what you have seen that maybe it tries to find the maybe the reason for a particular fault, and at the same time it makes sure that it provides a temporary solution. But in case of problem management, it tries to find the root cause of the problem. So what is the reason for maybe hardware failure and so on. Yes, if the complete solution is not available, the problem management provides a method to reduce or eliminate the impact of the problems. Problem management proactively analyzes the incident history and identifies the impeding service failures. So it identifies, resolves the errors before a problem occurs. Okay, so this problem management, it also works in the, see normally when you talk about this uh, um, or resolve any issues, right? So that would be done maybe proactive or reactive, right? So proactive in the sense before happening, maybe you just analyze, right? So based on the history, maybe you can predict that okay, this component may fail. So that is a proactive. Okay, reactive in the sense maybe once it has happened, maybe you take appropriate measure once the component fails. Okay, so the problem management is also responsible for what? So before a component fails, it analyzes, right? So these are all the incident, and there is a possibility that maybe this component may failure, right? If you take an example of maybe server, okay, if some a small incidents are happened, okay, then maybe the problem management has to take care that okay, this server is giving problem, so maybe it has to be replaced it with some other new servers. Okay, so similar to this incident management, so this also document the problem history. So that problem history are used for the maybe in case future some same problem occurs, right? So how then we get with this history we get an information, right? So because of this root cause, the problem has occurred and it is resolved using these methods and so on. Next is about availability management. Okay, so what is availability management? As the name indicates, the goal of availability management is to design, implement, measure, and improve cloud services, ensuring stated availability commitment are consistently met. In normally in the service level agreement, okay, you specify some of the performance components. So you make sure that so that the performance levels are maintained or it is available according to what is mentioned in the SLA agreement. Okay, so maybe SLA says that okay, your service is available for maybe 99.99 time or 90% it is available like that. So this availability management will make sure that okay, it is meeting the availability requirement. Yes, availability management ensures that availability requirements of a cloud service is constantly met. It designs and implements the procedure and the technical features required to fulfill the stated availability of the service. Okay, so in order to maintain, in the sense, in order to make maybe services available according to what is mentioned in the mentioned in the SLA, right? So what all the things to be done, so that will be taken care by this availability management. So some examples are given. Okay, so one is maybe maybe it is a part of this business continuity only, right? So implementing a redundant network path and the remote replications of VM files, right? Maybe you have that number of redundant path in case one path fails also, right? From maybe server to the backend storage device, maybe it can use the other path also. Okay, it need not be from the network path, it may be related to the other component also. Maybe it may be related to the port, or it may be host bus adapter or anything. And similarly, one more example given for this availability management is that clustering of physical servers, where server failure results in failure of services from failed server to another available servers in the cluster. All right, so this is also one of example for availability management. Okay, if any one server fails, all right, so some of the services running on that physical server, you need to move those services to other servers. Okay, to make sure that your service is always available. Okay, so how exactly it implements? Okay, that is availability management. So it continuously monitors and compares the stated availability and the achieved availability of cloud services, and identifies the areas where the availability must be improved, right? So it continuously monitors, right? So now what is the current available status and what is the stated availability, whether both are met or not. Okay, if not, okay, so improve, okay, make changes so that you can make the service always available. Okay, so now what is the input for this availability management? Yes, the input for this availability management is incident and problem management. So the input for this availability management is incident and the problem management. So this will provide a key input to availability management regarding the cause of service failures and time required to resume services. Right? Maybe if one, it is something like this. If one uh, maybe if one service fails and you have to failure to some other servers, okay, maybe before moving that particular service to other servers, okay, maybe you may get some information regarding those servers you through this incident and the problem management, right? So based on that, maybe you can decide that the service has to be moved to that server or some other server. Okay, so now what is the maybe advantage? Okay, having this of making all the services are available. It reduces the time of consumer to engage with the service desk. All right. Suppose if all services are functioning properly, then normally no customer will contact the service desk and asking for the maybe complaint saying that okay, this particular service is not functioning and all. All right, so which improves customer satisfaction, and at the same time it will increase the provider reputations. Right, if any service provider provide a service which is always available or up and running, so normally the reputation of the provider will obviously increase. Okay, and also from other hand, as the service availability level is raised, less staff is required to handle service desk and problem management. Okay, if any service, any cloud provider, okay, if they face when any less issues, right? So then the number of people required to manage those resources also very less. So the manpower required for managing those cloud resources also will be reduced. So this will increase or reduces the it reduces the administrative cost. Last one is about service catalog management. Okay, so in whenever this cloud offers a service, how exactly the end customer, okay, will know that which are all the services are offered by the cloud provider. So that will be specified in the form of that will be published in the catalog, right? Yes. So service catalog management involves creating and maintaining the service catalog. Okay. So the cloud provider will uh, uh, publish those services which are offered by that particular cloud provider in a what is called as the service catalog. Yes, it ensures that the information in the service catalog is accurate and up to date. So the service management brings in clarity, completeness, and usefulness when describing service offerings in the service catalog. Business drivers and technologies are ever changing, and consequently, cloud service are bound to change. Evaluate and upgrades the service catalogs continuously to include new services and improve in service offering. Okay, so there is a need for always update the service catalog. It is not like maybe once a cloud provider start offering the service and same service you cannot offer maybe over a period of time, right? So maybe you need to maybe after 1 or 2 year maybe you have to come up with a new service, all right? So uh, new service, it may be in terms of maybe hardware configuration, or it may be software, or it may be anything. Okay, if you keep only same old outdated service, then definitely the customer will migrate from current cloud provider to the other provider, right? So we have to update with the current requirement. All right. So now let's say that today we have uh, maybe the different kinds of processor, maybe 4 GB, 8 GB RAM and all, right? So maybe after 2 3 years, right? So the RAM requirement will be very high, right? Maybe 10 or 15 years before, when I brought my first computer, right, where the RAM size was 256 MB. Okay, and maybe uh, even hard disk also, I think maybe 16 or less, 16 MB, I think. So the pen drive which I had. Okay, but nowadays you cannot think of such a lower capacity of pen drive or RAM, right? So we need to update. Suppose if you offer same old services, as I mentioned, is the customer will going to migrate from the current cloud provider to the other cloud provider, right? It need not be for the same need not be for the same cloud. It applies for maybe any product also, right? So maybe if you take an example of Nokia, right? So how popular Nokia maybe some 15 20 years before, right? So maybe because of they are not upgraded to touch screen and all, maybe now you know the situation, right? Okay, now what are the information? As I mentioned, whenever the cloud provider offer any service, okay, the description will be available in the service catalog. So the cloud customer will look at that catalog, right, for each service. Then he decides whether to use a particular service or not. So what are the information? What are the informations are maintained? Okay, so for each service, you have a service name. Okay, so what exactly that service name is? Enables consumers to easily understand what a service is offering is, and by its name. In the description, which tells the consumers what the service is and what value the service provides, and the feature and options. Provides a list of options for selection, such as a list of operating systems and the virtual desktop service and so on. Right? For example, if a user wants to create a virtual machine, right? For this configuration, what all the operating system can be installed and all. So that everything should be mentioned. And service and support expectation. Yes, it describes the quality of service such as performance, availability, and security, and maybe a service desk. Okay, so the support, how many days they support, maybe whether they're from 24 into 7, whatever, everything should be mentioned. And price, so what is the price of for that service, right? So price list, then provisioning timeline. Okay, so how much time is required to provide that particular service, or if you are creating any virtual machine, okay, to create an instance, right? How much time is required? So all those things should be available in the service catalog. Next is about financial management. So what is financial management? So the goal of financial management is to manage the cloud service providers budgeting, accounting and charging requirements. So the financial management involves calculating the cost of providing a service. So calculate cost. So based on capex, that is capital expenditure, and opex, operational expenditure, administrator cost for providing the service. So plans IT budget for cloud infrastructure and operations, determines price for cloud service and ensures profitability. So monitors and reports on allocation and utilization of resources by consumers. So this ensures that consumers pay for what they actually use. Okay, so what exactly this financial management represents is for financial management. Okay, so as we are know that the cloud follows cloud follows what is called as a pay as you go model. All right, so pay per usage. All right, so suppose if you use maybe if you use one virtual machines of a particular configuration for 1 hour, okay, you have to pay this much dollar. So how it is decided? All right, so from the customer point of view, if you use maybe any virtual machine for 1 hour, okay, uh, maybe you don't need to, so there is no capital expenditure, right? But cloud, so whenever they want to offer that particular service, so they have to see, any provider will not, nobody will simply provide a service without any benefit, all right? So the purpose, even though say that, okay, it is maybe they provide a cheaper computing resource, finally they want to generate a revenue, all right? So when they are maintaining thousands of server and huge amount of the storage and network and all, you just think about the cost involved, all right, and from that they have to generate a revenue. So they have to think like maybe for how much cost maybe each virtual machine can be provided, and so on. So that is based on so there are many component, right? So how much capital expenditure, right? So they are providing a service in a sense, so they should have the capital expenditure, right? So they have to buy all the resources, right? So it may be compute resource, or it may be network component, or the storage component, right? So it may be maybe thousands of maybe the huge infrastructure. They have to invest for huge infrastructures, right? So what is the total cost? All right. So for the total cost, how they will generate the revenue. So what should be the cost for each computing resources? So that everything will be decided by what is called as a financial management. Okay, and also based on allocating the budget, as I mentioned, no, let's say that a cloud provider maybe initially invested maybe some amount of some dollar for initial infrastructure, right? Maybe after 2 3 years, the some of the component, the hardware resources will be outdated. Then once again they have to buy new resources also. That planning for that budget and all those things will be done by the financial management. Okay, and this is also responsible for monitors and reports allocation and utilization of the resources by consumers, right? It also provides like how much the consumer has consumed the resources and generating the bill, all right? So that also decided by the financial management. So this is also one of the important service, right? If this one is not functioning properly, then the provider will be under loss. Financial management performs a sequence of activities to enforce a chargeback for a service. Okay, now how he is going to decide a price for a particular service? Okay, maybe if you are using maybe virtual machine of some particular configuration, maybe 8 GB RAM and quad core processor maybe for 1 hour, what will be the cost? How it will be decided, right? So sequence of steps. Okay, that is common for any product also. Okay, so what are the different steps? The first one is activity one. So activity one is analyze and document all cost for providing the cloud service. All right, all the documents and all the costs of the different component for maybe for physical servers. Okay, what is the cost of that, and for the storage, and what is the uh, network related cost, and the power consumption, how much power consumes, and cooling, for cooling how much is required to manage all those things, how much is required. Okay, then after that, so that the total cost involved. Okay, then second one, identify billable unit, how it can be charged. Okay, the resources are charged in terms of what? Okay, with respect to CPU, maybe megahertz, gigahertz, or maybe RAM. Okay, if it is for maybe 4 GB RAM, this much price. If it is for 8 GB RAM, this much price, and so on. Okay, then based on that, define a pricing strategy for each billable unit. So that will allow for a recovery of cost identified in activity one. Then based on that, you decide a price. Okay, you decide a price so that maybe you have to recover whatever you have invested for the infrastructure. So that is activity three. Activity 4, so that is deploy tools to collect informations on resource usage, record billing data, and generate chargeback report per consumer. Right? Yes. The last one is about. So also you need to know about, okay, at any instance how much resources are used and what is remaining. Okay, and for the resource used by the customer, what is the chargeback? All those things will be recorded, or it will be dispatched to the consumer. Okay, so this is about the financial management or deciding price for the service. Okay, it is applicable for any component. Now let's say that maybe in a hotel, maybe for a tea, okay, they may charge 20 rupees or whatever it may be. Okay, so that is also based on the number of activities, right? Maybe they may start with the maybe for 1 liter milk, so what will be the cost, right? Then for that 1 liter milk, how much water they can put? Okay, then how much sugar, tea powder? Then from that, how many cups of tea can be made? And if it is sold for how much, then profit can be generated, and so on. So here also the same thing is applicable for this cloud services also. Okay, so next is about this compliance management. Okay, the goal of compliance management is to uh, ensure that cloud services, service creation processes, and cloud infrastructure resources comply with the policies and legal requirement. So which ensures that compliance requirements are fulfilled while configuring cloud infrastructure and provisioning cloud services. The compliance requirements primarily includes policies and regulations and external legal requirement. All right. So uh, before providing any service, it ensures that okay, it meets the compliance requirement. In the sense, it is meeting the policies and regulation. Okay, it is applicable for not only for the cloud service, in any services or any business. If you are starting also, it has to uh, meet the compliance requirement. For example, if you consider starting any engineering institution also, okay, so we have so all engineering institution coming under the umbrella of what is called as a ACT, right? So we have to any engineering college, they have to adhere to the policies and guidelines given by the ACT. So similar to this, it's the same thing is applicable for cloud service provider also. Okay, so the compliance requirement primarily include policies and regulations and external legal requirement. Okay, so now let us see what is that policy and regulations and external legal requirement. Okay, so first one is adhering to policies and regulations applies to both cloud service provider and consumers. Okay, these policies and regulations, it may be applied to both the provider as well as the cloud customers. Okay, so now what are the policies and regulations? Okay, it may be configuration best practices. Okay, maybe with respect to a virtual machine. So with what are the different configurations from which the service can be provided, and security rules such as administrator roles and responsibility, physical infrastructure maintenance timelines. Okay, so once they provide the computing resources, that has to be managed in the data center, right? How often the physical infrastructure will be managed, and the backup, how frequently the backup is taking, they'll be changing, or if you make any changes, right? So the change control process, such as any changes to cloud infrastructure resources and services. So those are referred to these policies and guidelines. Okay. Similarly, if I take general example, okay, maybe for any engineering institutions, right? Okay, if you want to start any engineering college, okay, maybe AICT or maybe we have some guidelines, right? So lab should be your laboratory should be of this much size, and only this many component can be placed, all those things will be there, so we have to adhere to those guidelines. So that is the policies and regulations. Okay, then second one, the second most important is external legal requirement. External legal requirements are data privacy laws imposed by the different countries. So these laws may specify geographical locations to store consumers' data and disallow modification and deletion of data during its retention period. For example, many countries do not allow financial data to cross country borders. So in this case, the compliance management must ensure that cloud infrastructure that provides the required service is located with the periphery of these countries, and data access is restricted to citizens of those countries. Okay, so this external legal requirement, it is mainly with respect to the data. Okay, so some countries may not allow maybe their financial data to be stored uh, uh, maybe in other countries. Now let's say that maybe some financial some company, they are hosting, they are using the cloud providers, okay, for storing their data. Now let's say that some financial company X says that they store data in the Amazon data centers. So Amazon, they have the data center across the globe, all right? Okay, so they may have some restriction that saying that, okay, so your the financial related data, it should be stored in maybe the data center in India itself. It should not store it in some other countries also. So these are all the external legal requirements. So the compliance management periodically reviews the compliance enforcement in infrastructure service and services. Okay, so these requirements will may change day by day. All right, so it should, the compliance management will adhere to whatever the changes which will happen maybe day by day. Yes, if it identifies any deviation from the compliance requirement, it initiates the corrective actions. Right? If they find any deviation and all, it find the corrective action. One example is, initially it may allow that maybe you can store the data in other country data center. Later realize that maybe it should not be done. Maybe you have to take some corrective measures. Okay, so the same thing here, the compliance example. Okay, so that compliance management mainly talks about policies and regulation and external legal requirement. So external legal requirement mainly talks with respect to the placement of data, and where exactly who are the customer can access that particular data. And policies are referring to maybe best practice, security rule, and the infrastructure maintenance timeline, backup schedule, and so on. Okay, so next is about service management automation. So several activities in cloud service management may be automated using the service management tools. Service management tools may be integrated with the cloud infrastructure management and the service creation tools. Okay, whatever we have mentioned, the different processes, right? So it may be capacity management, performance management, incident management. So everything, the most of the things which is mentioned, it can be automated, right? So you need not do everything manually, right? So that is what mentioned. So manual approach to cloud service management is subjected to errors and difficult to audit, right? So the most everything what is mentioned can be automated. So what is advantages of automation? Yes, it reduces the manpower required. Okay, so here some examples are given. So what are the things which can be automated and all? Right, one is a CMDB population. Right, so uh, the database which we have discussed about service asset and the configuration management. So that database automation also it can be uh, the updation of CMDB database also can be automated. And similarly, and incident and problem creation. All right, so that also can be automated. Now, let's say that if one server is not functioning, like how do you know that a server is not functioning or not? Right, you don't need to manually go and check whether service is up and running. All right, so it can be automated. Maybe you can make sure that some automated some component, okay, some agent process which is running in the that server, which periodically sent some heartbeat information. All right, if in case if you don't receive heartbeat information, all right, then we come to know that okay, there might be problem in that particular server and so on. So that is what incident and the problem creation. So all those things, the continuously monitoring availability and the performance of cloud infrastructure and the deployed service. Okay, and automatical registration of incident and all. So all those things can be automated and analyze and forecasting, right? So identifies unused and over allocated capacity to the virtual machine and reclaiming, all right? Reclaiming or adding additional resource, that also can be automated. No need to explicitly add additional resources, all right? And similarly, bill, okay? So normally when you use a virtual machine for maybe n number of hours, okay, then automatically the bills will be generated. So human interaction is not required. So that's what. So the most of the things what is mentioned, everything can be automated. All right. So in maybe in near future, maybe after 10 years, maybe you don't have anything like. So the software engineer has to uh, no need to write any code from the scratch. So everything will be automated. Okay, so that's what mentioned here, right? So this service management automation, which results with the avoidance of human errors, automatic auditing, reduce time and effort to manage services, reduce administration cost, and so on. Okay, so this is about the service management automation. Okay, so next we look at what exactly the horizontal and vertical scaling. Okay, so this horizontal and vertical scaling is nothing but it is a method of adding more resources for a particular applications. Okay, you are scaling the resource. How you are going to scale the resources? So there are two ways. One is a horizontal scaling, and another one is a vertical scaling. Okay, so now what is horizontal scaling? So horizontal scaling in the sense which will add more node to the system, adding more node to the system. That is what is called as a horizontal scaling. Now let's say that you are running one business application in one virtual machine. One virtual machine, your business application is running. Okay, maybe over a period of time there is a more load on that particular server, more load on that particular server. So in that case what you can do is, okay, instead of one virtual machine you can create multiple virtual machines. So that is what is called as a horizontal scaling, and it is also called as a scale out. Okay, scale out, or you are creating multiple virtual machines. Okay, anyhow for this you need a front end load balancer also. So normally when you talk about this MEC architecture, right, so where you'll be having maybe one front end and number of business or presentation tier and application tier and database tier, right? So based on the requirement, so one of the node can be increased. So that is what is called as a horizontal scaling. Okay, increasing the number of nodes or increasing number of virtual machines. And the second one is a vertical scaling. So now what is vertical scaling? Vertical scaling in the sense adding the resources to the existing node itself, adding the node to the existing node, adding the resources to the existing node itself. Now let's say that you already created a virtual machine with the 4 GB RAM and some compute. Maybe over a period of time you come to know that maybe there is a more load, right? So in that case, instead of creating one more virtual machine, you just increase the RAM capacity. Okay, maybe from 4 GB RAM to you are increasing 6 GB RAM. So that is what is called as a vertical scaling or scale up. Vertical scaling is also called as a scale up, and horizontal scaling is a scale out. Okay, so normally the current provider, they provide what is called as a horizontal scaling. So that means whenever there is a more load, there is a provision for increasing the number of nodes. In human analogy, what we can say is that if you look at the life cycle of any human, right? So we start with the life cycle start with the vertical scaling, then horizontal. All right. So when a child is born, maybe is of maybe 1 or 1.5 feet. Okay, then maybe we increase to 2 feet, 3 feet, 4 feet, five. Okay, height of that person. Okay, 5 or 6. Then that vertical scaling will stop. Then what horizontal scaling? Okay, the person becomes a fat. Okay, that might be treated as a horizontal scaling, or he may get married. Okay, one becomes two, and he'll be having child. That is horizontal scaling. Okay, so next we look at the cloud resource management and scheduling. As we are already maybe looked at in the earlier chapter, that a cloud is a complex system which contains maybe thousands of servers, okay, which is shared among multiple users, and uh, uh, which may encounter the different unpredictable loads, right? So normally this will affect the three basic criteria for evaluating the system, that is performance, functionality, and cost. All right. So suppose if you don't manage these resources properly, all right, so definitely it will have a negative impact, right? It may on the performance or functionality or the cost. Okay, so to efficiently manage these cloud resources, okay, so cloud resource management requires complex policies and decisions, okay, so which are of multi-objective optimization. Now, what is the main problem with respect to the cloud resource management? Cloud service providers are faced with the large fluctuating loads that challenge the claim of a cloud elasticity. Okay, so one of the feature what we talk about cloud is that cloud is elastic, right? So elastic in the sense whenever based on any workload where you can increase the resource, the cloud elasticity. But the problem is that so that the load which encounter on that particular application which cannot be predicted, right? So in some scenario it may be predicted, and in some scenario it cannot be predicted. So when the spike can be predicted, the resource can be provisioned in advance. So for web service subject to seasonal spikes. Okay, for example, if the load is already predicted, if the load is already predicted, then maybe you can provide additional resources, right? So one example is something like this. Now let's say that maybe university is hosting their website, okay, in the cloud. maybe they know that when there is a huge load on that particular server. Okay, so the load on that particular server or an application only during when they are going to announce the result. Okay, so whenever they are going to announce the result, then in that case, that day there will be heavy load on that particular server. Okay, so that spike can be predicted. In case if it is predicted, okay, before only they can increase the resource, right? So they can scale out that application instead of one application. They can scale out. They can host that in a multiple virtual machines. Okay, but in case of unplanned spike, right? Unplanned spike, maybe it is very difficult to provide the required resources. That's what for unplanned spike, the situation is slightly more complicated. Auto scaling can be used for unplanned spike load, provided that auto scaling can be done. So in the sense, now let's say that initially it is having maybe some load. Suddenly, when the load is heavy load on that particular server, okay, maybe auto scaling can be performed, provided that maybe there is enough resources are available. So that is what auto scaling can be used for unplanned spike load, provided that there is a pool of resources that can be released or allocated on demand. And there should be a monitoring system which periodically monitors, right? So periodically monitors whether the load is stagnant or maybe there is a more load on the server, right? So the continuously monitor, and if there is a more load, then maybe you can provide additional resource. In the sense, you provide additional virtual machines. Okay, next is about, as I mentioned, these policies and mechanism for resource management. Okay, so now what exactly the policies and the management? So policy normally refers to what? A policy typically refers to the principal guiding decisions. And whereas uh, mechanism represents means to implement those policies. Okay, so the policy actually refers to the principal guiding decisions, and mechanism refers to how we are going to implement that particular policy. How we are going to implement that particular policy. For example, now with respect to education, right now we are talking what is called as a national education NEP 2021, right? So new education policy, how we are going to implement that. Okay, so now with respect to this cloud resource management policies can be loosely grouped into 5 classes. So these are the different policies. Okay, what are the different policies? One is the admission control, capacity allocation, load balancing, energy optimization, quality of service guarantees. So these are the different policies, right? So one is about admission control. The name itself tells about what exactly this policies talks about. Okay, the goal of admission control policy is to prevent the system from accepting workloads in violation of high-level system policies. For example, system may not accept additional workload that would prevent it from completing work already in progress or contracted. Admission control. So whenever you host any application, so definitely so there will be a number of requests, all right? So there is a number of requests, so that is represented in terms of load, all right? So when it encounters, it should have some threshold. When it is more than that particular threshold, it should stop accepting that particular request. That is what is called as the admission control. If you keep on accepting the load, what happens? It will affect other application which is already running also. So that is what is called as a admission control. So admission control, what is the goal of admission control? Is to prevent the system from accepting workload in violation of high level system policies. Okay, then second one, capacity allocation. What is capacity allocation? Yes, as the name indicates, yes, it talks about allocating the resources for the particular instance. To allocate resource for the individual instance may be virtual machine or whatever it may be. That is what is called as the capacity allocation. Okay, next is about load balancing and energy optimizations. Load balancing and energy optimization. Yes, load balancing and energy optimizations are correlated and that affect the cost of providing the services. Okay, so both are interrelated, load balancing and energy optimization. But normally, when you talk about this load balancing, it is something like this. We are equally distribute the load on all the server. That is what the concept about this load balancing, right? For example, let's say that there are four servers. Okay, four servers are A, B, C, D. Okay, and let us assume that the load on each server is 80%, 60%, 40%, and 20%. Okay, that is the load on each server. So now, so there are four server, and the load on each server is like this. When I say load balancing in the sense when you just add this uh, 80, 20, 100, and this also 100. So that means load balancing in the sense, according to you, divide by 4, you'll get the 50%. So there should be 50% load on each server. That is what will come to our mind when we talk about load balancing. Right? So all servers should have equal load. But in case of here, load balancing should consider energy optimization. Load balancing should consider the energy optimization. So the critical goal is to minimize the cost of providing the service. In particular, minimizing the energy consumptions, minimizing the energy consumption. At the same time, we have to make sure that we have to reduce the energy consumption. So how energy consumption can be reduced? Now there are four servers are there. All right, four servers are there, and the loads are already mentioned. Instead of four servers, can we provide the four? Can we provide allocate those loads in a minimum number of servers? Can you do that? All right. So with respect to this, you just look at here. So four servers where server A is 80% loaded, and B is 60%, and C is 40%, and D is 20% loaded. Can you move the load? Okay, load that is of 40% to the load on C to B, and similarly for D to A. Move the application, whatever the application which is running on server C and D, you move that to A and B. Okay, so that A and B will be loaded 100%, and C and D there is no application is running, so that server C and D can put in standby mode. Okay, so that it will consume the less energy. Okay, you don't need to switch on the server, or you can put last two servers in the standby mode. Only two servers are running, other two servers are not running, so that you can reduce the energy consumption. Okay, so next is about this quality of service. Okay, so quality of service is that aspect of resource management that probably the most difficult to address. So normally when you talk about this resource management, okay, so that jointly target on performance as well as power consumption. Okay, so resource management not only talks about the performance. Okay, resource management not only aims on, so we have to provide cloud service with that particular performance. It is not like that. At the same time, it focus on the power consumption also. How much power is consumed? So that service is offered with the how many number of servers and all. As you run more number of servers and all, so there will be more consumption. So energy consumption, which will leads to more cost. See, now the recent the processors like which provides what is called as a DVFS, that is a dynamic voltage frequency scaling, DVFS. Okay, so that is provided by Intel's processor. So that is the speed step, and similarly AMD they have the processor called as the power new. Okay, they with that they provide a facility called as where you can increase or decrease the frequency. Okay, the frequency, so that is in case as a result the lower the voltage or frequency, Okay, whenever if you decrease the processor frequency, what happens normally? It will decrease the energy consumptions. Okay, any processor where you can decrease the frequency. Normally we talk about the frequency of this hertz and all, right? You can decrease the frequency. When you decrease the frequency, what happens? The energy consumption will be reduced. If you decrease the frequency, energy consumption will be reduced, but at the same time it affects on the performance also, right? As you decrease the frequency of the processor, the energy consumption is also reduced, and at the same time the performance also gets decreased. Okay, so now this table shows one example. This table shows one example where first column represents the CPU speed in terms of gigahertz. Okay, so that is 0.6, 0.8, 1, 1.2, 1.4, and so on. And the second column shows energy consumption. Okay, energy consumption. What you can see is that as the frequency increased, CPU speed increases, energy consumption also increased. Energy consumption also increased. And the performance, when you look at the performance also gets increased. As the frequency is decreased, and at the same time, the energy consumption also decreased. Energy consumption also decreased, and the performance also decreased. Now you have to find a trade-off, right? So what is the best frequency for which it gives better performance? At the same time, the energy consumption is also reduced. Energy consumption also reduced. Now you just to look at the last row. You look at the last row. So that is at a speed of 2.2. Okay, energy consumption is very high. Okay, fully it consumes fully energy consumed, and performance is also very high. You will get a better performance, but the energy consumption is also low. Then you look at the last but one row. It provides the performances of 99%. Okay, you are ready to compromise for maybe 0.1%, but that results with the is power consumptions, right? So the power consumption is reduced by 0.1. Okay, if you are ready to compromise for 0.1 performance, it results with what? Maybe the energy consumption also get reduced by 0.1. And similarly, if you are ready to compromise by maybe you are ready for the performance of 0.95, okay, then you can see that energy consumption is reduced by 18%. Okay, 18%. Suppose if you are ready for 5% of compromise with respect to the performance, okay, there is a reduction in the energy consumption, 18% reduction consumption. All right, so based on that you have to decide. All right, decide about the frequency, right? With what frequency, if a particular processor runs, which will reduce the energy consumption, and at the same time it gives some better performance. Okay, in a summary, what I can say that, right, as you decrease uh, uh, the frequency, the processor frequency, the energy consumes also reduced, and at the same time performance also reduced. So now you have to select maybe some suitable frequency such that there is a compromise between energy and the performance. Okay, so we have okay, only 5 minutes, right? Okay, so this is about uh, the different policies, right? So we have seen admission control, capacity allocation, load balancing, energy optimization, and quality of service. And normally when you talk about this, all optimal mechanisms, okay, optimizing all is very difficult. Okay, all optimal mechanisms to address 5 classes of policies, which will not scale up. You have to compromise with one. You cannot get optimal value for all. Okay, maybe you have to find the trade-off between any two. Okay, so this is about this 5 policies. Okay, rest we will cover in the next lecture.